Hello everyone, and welcome. We're about to embark on a journey into the truly unknown, a cosmic enigma that's unfolding right now, out there in the vastness of space. We've given it a name, Oumuamua. But here's the fascinating part, that name doesn't tell us what it is, or what it's doing. Oumuamua is different. It looks different, it moves differently, and it's composed of materials that defy our current understanding. And as we've dedicated ourselves to studying this object, a new possibility has emerged. What if it's been studying us for even longer? Let's start with some breathtaking recent images of Oumuamua, captured by dedicated astrophotographers in the remote desert of Namibia, on the southern tip of Africa. This is already an incredibly dark place on Earth, but these photographers seized an extraordinary opportunity during a lunar eclipse. The Earth's shadow effectively blocked out all sunlight from reflecting off the moon, creating the darkest possible sky and, consequently, the clearest view into the cosmos. In that moment, with the universe laid bare, they chose to focus their lenses on Oumuamua, and what they witnessed was astonishing. The object was glowing a vibrant green in the night sky. Now, based on everything we understand about Oumuamua, it shouldn't be green. Or, at the very least, there's no readily apparent natural explanation for this color. You see, the prevailing scientific theory suggests Oumuamua is an interstellar comet. This means it's fundamentally similar to other comets we observe traversing space. It possesses a large, luminous halo of gas and dust, known as the Comet, and a sweeping, fan-shaped tail. However, this comet is distinct because it originated from an entirely different star system, from some distant corner of the galaxy. So, we anticipated it might be a little unusual. But the perplexing aspect of Oumuamua is its consistent tendency to behave in ways that simply don't align with our expectations. For instance, it's not inherently uncommon for a comet to appear green. We have a solid grasp of the chemical processes that create this hue. It occurs when carbon molecules within the coma are exposed to ultraviolet radiation from the sun. Specifically, this affects diatomic carbon, or C2, which consists of two carbon atoms bonded together. Therefore, if Oumuamua were a typical comet, it would be rich in these carbon structures on its surface, and it would naturally turn green under sunlight. Yet, observations made throughout the summer, utilizing virtually every major telescope available, indicate that Oumuamua is actually deficient in these C2 molecules. It appears to lack C2, and yet, it's undeniably glowing green. So, why is this happening? We don't have a definitive answer. Perhaps it's a cosmic curiosity, a celestial preference for green. We also know that the coma surrounding Oumuamua is filled with CO2, carbon bonded to oxygen atoms. This is fundamentally different from C2. While it certainly contributes to the object's remarkable brightness, it wouldn't produce a green color. Furthermore, the sheer abundance of CO2 is itself quite peculiar. It vastly outweighs the amount of H2O, or water vapor, in the coma. This is essentially the opposite of an average comet, which typically contains significantly more water than CO2. But that's not the only anomaly within Oumuamua's coma. It's also teeming with metal, particularly nickel. Again, while metals aren't entirely unheard of in comets, it's unusual for Oumuamua to be exhibiting this characteristic at this particular stage. Many comets contain metals in their composition, and these metals can sometimes evaporate into the coma. However, this process typically only occurs when a comet ventures extremely close to the sun, where the intense heat is sufficient to vaporize metals. Oumuamua is not in close proximity to the sun. The presence of nickel was first detected when it was still traversing the region between Mars and Jupiter. This leaves us without a reasonable explanation for its release of abundant nickel, unless we consider the intriguing possibility that Oumuamua is not a comet at all, but perhaps an alien spacecraft. In such a scenario, rocket engines are often constructed from metal alloys with high nickel content, and their exhaust gases would naturally contain significant amounts of nickel, along with CO2. Of course, this is a speculative thought, but it's one that arises from the data. Beyond its composition, there's something equally peculiar about Oumuamua's movement through our solar system. While likely unrelated to hypothetical rocket engines, its trajectory and velocity have remained remarkably consistent throughout the entire period of our observation. From its initial sighting in early May until now, in October, it hasn't significantly sped up, slowed down, or altered its direction. This might not sound extraordinary, but for a comet, this level of stability is highly unusual. Comets, As they approach the sun, heat up, causing them to sublimate, a process where a solid transitions directly into a gas. The release of this gas acts like a thruster, subtly pushing the comet around in space. A typical comet's velocity and direction will fluctuate depending on which side is exposed to the sun. We refer to this as non-gravitational acceleration, or NGA. We usually measure the average daily variation. As we've observed, Oumuamua has already undergone significant sublimation, even forming a small tail in the direction of the sun, which has since evolved into a longer tail extending away from the sun. Yet, on a daily basis, its velocity and trajectory have only deviated by about 1.5 kilometers per day in NGA. Let's compare this to Toei Borisov, considered the most normal of the interstellar visitors. Its NGA was measured to fluctuate by over 100 kilometers per day, roughly 100 times more movement on average than Oumuamua. One might suggest that Oumuamua is simply larger, and therefore harder to influence. That's a logical thought. But let's bring in another comparison. Comet Hale-Bopp. This was one of the largest comets ever discovered in our solar system, at least as large as Oumuamua, if not considerably bigger. Hale-Bopp exhibited an average NGA of over 10 kilometers per day, again, about 10 times more than Oumuamua. And Oumuamua dwarfs them all. At certain points, it was changing direction by over 1,000 kilometers per day. So, even when compared to other interstellar objects, Oumuamua is moving in a profoundly strange way. It maintains such an unusually steady course that one might almost perceive it as intentional, as if it's being deliberately guided through the solar system. While there's likely a natural explanation for this, let's entertain the idea that if Oumuamua is a vessel, it not only possesses the ability to maintain a course, but could theoretically alter it at will. Currently, our projections indicate that Oumuamua will pass through the inner solar system on the opposite side of the sun from Earth. This means we won't have an opportunity for close observation, and it won't have a chance to observe us, unless Oumuamua somehow manages to decelerate as it passes the sun and is found waiting for us on the other side. Now, here's a truly captivating theory that might just hold some weight. Have you ever heard of the WOW signal? It was detected in 1977 by astronomers at Ohio State University using a radio telescope known as the Big Ear. This instrument was designed to listen for unusual phenomena in space. On one particular day, it picked up something so extraordinary that the researcher analyzing the data simply wrote "WOW" on the printout, giving the signal its name. What astonished them was an incredibly powerful, narrowband radio signal that lasted for 72 seconds and originated from a point deep in outer space. We know it wasn't from any of our own technology, nor did it come from the sun or any planet within our solar system. All we knew was that it emanated from the general direction of the constellation Sagittarius. The first striking aspect of the WOW signal is the immense energy it would have required to broadcast a narrowband radio frequency across interstellar distances. If it were of extraterrestrial origin, it would imply a civilization capable of harnessing the energy of a star. Alternatively, if it were a natural phenomenon, it would suggest some form of stellar activity. The second crucial element of the WOW signal relates to hydrogen, the most abundant atom in the known universe. There's a specific radio frequency associated with hydrogen atoms, known as the hydrogen line. While this is a simplification, the key takeaway is that the frequency of the hydrogen line is 1420 MHz, and the frequency of the WOW signal, you guessed it, -1420 MHz. If one were attempting to send a simple, universally recognizable message across the galaxy, this would be a logical choice. In the 5 decades since, we have never detected another radio signal that remotely resembles it. The reason this is so relevant now is that astronomers have been able to reverse engineer the trajectory of Oumuamua, and we are quite confident that it also originates from the general direction of the constellation Sagittarius, the same region from which the WOW signal was detected. This is a remarkable coincidence, leading some to speculate that the true source of the WOW signal might not have been a distant star, but perhaps our current visitor, Oumuamua. In 1977, Oumuamua would have been on the outer fringes of our solar system, far beyond the orbit of Pluto. Perhaps it was simply sending a preliminary greeting, a heads up that it was on its way. Naturally, this remains a theory, one that hasn't been definitively proven and likely never will be. However, it also hasn't been definitively disproven. And that, perhaps, is the most important perspective to maintain as we continue to learn more about Oumuamua. Objects like this challenge us to keep an open mind to the boundless possibilities of the universe. The truth is out there, and it's heading our way. Thank you for joining us on this exploration. If you found this journey into the unknown as fascinating as we did, please consider following for more cosmic discoveries.